Welcome, focused learners. Today, we're jumping right into a really fascinating, highly regulated world of heavy-duty maritime engineering. We're looking at the Hyundai Atlas MAXI NG50SL W waste oil incinerator. If you've ever wondered how massive commercial ships actually deal with all their waste oil and garbage out in the middle of the ocean without destroying the environment, well, this explainer is exactly what you need. We're going to break down the technical manual so you can really get a feel for the incredible engineering happening under the hood here. Okay, let's dive into this. Here's our roadmap for today. We're going to cover 1. Basic function, 2. Core components, 3. Standard operation, 4. Essential maintenance, and finally, 5. Troubleshooting. Section 1. Basic function, the core purpose of marine waste disposal. So picture this. You're out at sea and the ship is generating tons of hazardous and non-hazardous refuse. You absolutely can't just toss it overboard. International maritime laws are incredibly strict about this, and for good reason. So this machine's job is to safely and cleanly eliminate that waste right there on the ship. To put the sheer power into perspective, the MAXI NG50SL WS has a maximum capacity of 320,000 kilocalories per hour. That is just a staggering amount of thermal energy. We're talking about temperatures inside this thing exceeding 1,200 degrees Celsius. The stakes are super high, which is why really understanding how this beast works is absolutely crucial for the crew. To handle that intense power safely, the incinerator relies on a brilliant multi-chamber design. It's kind of like a giant industrial digestive system. The primary combustion chamber acts as the stomach. This is where the actual solid waste and waste oil get burned. But, of course, burning that stuff creates dirty exhaust. Enter the secondary combustion chamber. This acts like a definitive thermal filter. It completely burns off any lingering uncombusted exhaust gases or particles before they ever have a chance to escape out the ship's funnel. Section 2. Core components. Anatomy of an incinerator. Now, what's really interesting about this slide is how it takes all that complex jargon and maps out the whole flow of the system. If you follow the path, you can see the waste oil tank feeding right up into the unit using the dosing pump. You've got the charging door where the crew manually loads solid waste straight into that primary chamber. And, absolutely crucially, if you look toward the top, you've got the flue gas outlet. That ensures that once the secondary chamber has finished its filtering job, the clean emissions are safely expelled. Grounding ourselves in the physical space here, it's wild to see how tightly packed this engineering marvel really is. This physical footprint houses the very lungs of the system. You can easily spot the primary blower attached right to the side, and its entire job is to forcefully drive combustion and cooling air through a really complex network of air nozzles tucked inside those double steel walls. So let's quickly detail these essential organs. You've got the primary blower supplying all that necessary air. Then there's the waste oil, or WO dosing pump. That's a self-priming positive displacement pump literally feeding the fire. You've got your primary and secondary diesel oil burners kicking things off with high-pressure flames. And overseeing the whole shebang, that's the PLC control panel. It acts as the brain and nervous system, automatically tweaking the feeding capacity based on real-time sensor data. Section 3. Standard operation, step-by-step operating procedures. Now, you do not just walk up and press start on a machine churning out 320,000 kilocalories an hour. No way. The prep phase is incredibly rigorous. First, the operator has to open the diesel and compressed air valves. They literally have to physically check that nothing is blocking the air admission and that the ash and sluice doors are locked tight. Another critical step, ensuring the waste oil in the tank is preheated to exactly 60 degrees Celsius so it flows perfectly. And finally, you got to make sure those air nozzles are totally clean before you even think about touching the start switch. Once everything is prepped, the operator uses 2 distinct operating modes programmed into that PLC brain. MD1 is your default waste oil burning mode. When you turn the main switch on, it defaults right here, and it's actually clever enough to handle burning waste oil and solid waste at the exact same time. On the flip side, MD2 is strictly for solid waste burning. You have to manually select this on the touch panel if you're only disposing of solid garbage. It's a great example of how the machine instantly adapts to whatever the crew needs on any given day. Let's look at this automated timeline of heat. When you finally hit start, the blowers kick on immediately at 0 seconds to purge the system. At 60 seconds, preheating starts as the secondary diesel burner fires up. But here's the kicker. The primary burner, the main event, will absolutely not ignite until a sensor confirms the secondary chamber has hit a staggering 650 degrees Celsius. Once the waste oil starts burning, the system is chasing an optimal 950 degrees Celsius. It uses PID autocontrol, which is basically a continuous mathematical feedback loop to perfectly regulate the feed. It really is this highly choreographed dance of fire and sensors. But amidst all this smart automation, the manual drops a very real, stark warning. Warning: do not put explosive materials, close containers, or aerosols into the combustion chamber. I mean, think about it. At 950 degrees Celsius, a simple closed container literally becomes a lethal bomb. The physical stakes for the crew sorting that garbage are incredibly high. Let's move to and see how this builds into Section 4, Essential Maintenance, Preventative Upkeep for Optimal Performance. Running this safely requires strict, scheduled care. The manual lays out some really specific intervals. Every 500 working hours, you have to clean soot off the flame detector's photocell. Hit 1,000 hours, the waste oil burner needs a full clean and inspection. By 2,000 hours, you're entirely replacing the primary and secondary burner oil nozzles. And at the big 10,000-hour mark, you've got to change out the bearings on all the fully closed electrical motors. And this brilliantly illustrates the actual official scheme for maintenance straight from the source document. It validates exactly what we just talked about, but goes even deeper, detailing checks for solenoid valves, the refractory lining, and self-cleaning strainers. Skipping these checks, it doesn't just mean the machine runs poorly, it means you're risking a catastrophic failure out at sea. Section 5. Troubleshooting. Diagnosing common system breakdowns. Okay, so what happens when things go wrong? One of the most common headaches is the primary or secondary burner flame failure alarm. The troubleshooting charts are pretty dense, but we can simplify it into a clear problem solution matrix. If that alarm screams, you check 3 main things. Soot on the flame detector, clean the glass. Obstructed oil nozzle, clean the filter. Or if the pump is running but the flame just keeps failing, the stator might be damaged, which means a full replacement. It's a very logical process of elimination kind of deal. Then you have the terrifying high-temperature alarm for the combustion chambers. If this goes off, operators first check if the thermocouple connection cable got interrupted and is giving a false read. But if the sensors are fine, it almost always points to human error. Usually, somebody loaded way too much high-calorific waste, like plastics, into the chamber. Remember, the manual is strict. Solid waste must never ever exceed 20% of the chamber's volume to prevent an explosive combustion event. And finally, the ultimate safety protocol. The manual notes that right on startup, oscillating combustion can happen. If the machine starts doing this, the rule is blunt. Stop it immediately by hitting the manual stop switch. The PLC is super smart, sure, but at the end of the day, it completely relies on the situational awareness of the human standing right next to it. So what does this all mean? We've seen the 320,000 kilocalories of heat, the multi-chamber design, the PLC brain, and those rigorous maintenance schedules. With so many moving parts, precise sensors, and extreme temperatures on the line, is the true engineering marvel the Hyundai Atlas Incinerator itself, or the highly trained maritime crew that meticulously maintains and safely operates it every single day? Thank you for joining me on this Explainer Focus Learners. Keep analyzing, keep exploring, and I'll catch you in the next one.